So the best innovative software at the end of the day, we need the right hardware partners. So when you don't build hardware, you need to find the right partners for networking, for servers, for flash, and even better if somebody is thinking about data center scale and looking at the entire picture. And Open19 for us is that, and that's why we ask Yuval to come and talk about what they do and how does it fit into the story.
Hi, good afternoon, everybody. I know I'm between you and the beer, so I'll go.
Oh, it's okay. I'm interested in Open19.
Yeah.
I want some of that crap in my lab.
My name is Yuval Bachar. I'm a principal engineer at LinkedIn, responsible for all the data center next generation development. Open19 is a project that we started as an internal project. It was not expected to be a big project coming to the outside. After we shared some of the information with some of our peers, we got feedback so strong saying, oh, you have to open it up and we have to make this an open technology. That, in the last 6 months, actually resulted in the Open19 technology being developed and shared across the industry. And I'll touch on Open19 technology today. For LinkedIn specific, just a few numbers about LinkedIn. We currently had about 500 million users, about 150 to 200 active ones. We have 5 data centers in the world, footprint of about 150,000 servers. And Open19 will take us to the next level. As you all probably know, Microsoft acquired us. So as a result of that, we actually need to go to a much larger number in the footprint just to accommodate the Microsoft requirements. So let's start with what were the goals when we started. We went and checked all of our data centers and checked all of our peers' data centers and said, okay, what is the only thing or the most common thing which we can actually associate our design for? And I think the cleanest one that came back is 19-inch rack. You have to fit into 19-inch rack, and that's common for every location, every continent, every colo, every specialty data center. It has to be 19-inch. So we said, okay, 19-inch rack is our baseline. We have to put storage, networking, and compute in it. The second level was, okay, we want to create a solution which will be able to be applicable for large environments, medium-sized environments, and smaller environments. For us, it was really critical at LinkedIn because we have a variety of environments. And in reality, what we are building, the smallest footprint we're building for Open19 is a 16-server micro data center that we're putting in our edge platforms with a power shelf and a networking switch. The largest one is the one that we have in Oregon, 150,000 servers, leveraging exactly the same technology, exactly the same servers, the same power distribution, the same networking connection. We wanted to also bring a situation that we're actually reducing the cost of the racks. Racks in general are really expensive. If you look at smart PDUs, they cost thousands of dollars. Actually, surprisingly enough, they cost more than networking gear, smart PDUs. If you look at the racks themselves, if you look at cabling became a really big problem for us from a cost perspective. So we said, okay, we need to cut the cost off the rack, empty without server, and then take the server to the next level. The next aspect is we want to do very fast integration. For us at LinkedIn, we actually integrate on the floor, which means we bring the servers to the floor, we integrate on the floor. We don't do rack and rolling. Today, it takes us about 7 to 8 hours to load the rack with a trained technician, hook it up, connect the power, hook up the networking gear, run it up. With Open19 technology, we had a goal to cut it by half or 3 times better. We actually achieved much better than that. The current testing we're doing in the lab, an hour and 20 minutes, we load 96 servers into a rack. And lastly, we wanted to create a situation that would build a community. We understood that by ourselves we're not big enough. We have to create a community, we have to create an ecosystem that will feed itself and enable a volume of servers that will be in the range of 1 million servers a year. Our partners right now, the way we see them, represent about 1 million servers a year. And I can't mention all the partners because we had not officially announced it, but you can look at all of our mid-tier data center operators, they're all in there. Some of you are looking at their feeds over there. Okay, this will work. We had a couple of non-goals. One is we didn't want to create a proprietary form factor. There's plenty of them out there, from OEMs, from open source, non-open source. There's OCP happening right now with a lot of those proprietary form factors. We said if this is not a form factor that everybody is adopting, then we have a problem. Then we did not succeed. Based on what we see right now, there's a high level of adoption, and we can actually be able to be successful with this solution. And the two other aspects is we want to create a very open environment that enables us to create a fast turnaround of engineering development and a fast turnaround of building a community. Eliminate all the bureaucracy and eliminate all the organization, which actually has all kinds of committees and boards and committees of boards and boards of committees to approve what you can and what you cannot contribute to
We're
open
meeting with them
source.
Friday.
Yeah. So we eliminated all of that and said, this is not going to happen. Okay? Then we created a couple of philosophies that we want to operate under. Whoops. Come on. Okay. The first philosophy that is driving us and driving to this technology is everything in data center needs to be disaggregated. Which means for us, everything in data center is a server. If it's a switch, it's a server with a lot of ports on it. If it's a storage server, it's a server with a lot of storage elements on it. If it's a compute server, it's just a server with a lot of compute power, but they're all servers. We treat them the same, we provision them the same, we manage them the same, we monitor them the same. That was the first aspect of what we're doing. Disaggregation has a lot of meanings in different places, but the way we look at disaggregation is every element is independent, but they all coexist together and create a virtual environment for our cloud. Okay? We want to create a situation that we don't have appliances in data center anymore. In reality, when you look at appliances, storage appliances, firewalls, load balancers, what are those? Those are servers. That somebody puts a package of software on top of it, mark it up 10x, and is trying to sell it to us. From our perspective, there's no reason for us to do that. We want to buy software packages. That's why the accelerator solution is perfect for us, because we are disaggregated. We have hundreds of thousands of servers with different configurations of NVMe technology in them. Driving a client to every one of those servers and sharing that storage technology across all of our data center is perfect for us. That's why it's in line really well with our philosophy of doing shared technology across all of our servers. And in our future developments, all of our Open19 technology will leverage a software-only solution for storage management and storage distribution. From our perspective at LinkedIn, we are extremely focused on SSD. Most of our storage nodes are going to SSD. And with the fact that we become Microsoft, SSD became much more affordable for us because the volumes that Microsoft represents is much, much bigger. So SSD is going to be all of our future technology. SSD in NVMe format is actually the one that we actually chose as our primary one. And again, that's where the linkage with Accelerator happened to actually create a software-based solution that will enable high-performance NVMe technology in our data center.
Are you using U.2 or add-in cards?
So we are doing a combination of U.2 and M.2s. Okay. Microsoft is mostly operating on an M.2 configuration.
All right, I saw that Microsoft thing.
But they have an adapter which is doing conversion between U.2 and M.2.
Right.
So that adapter is actually going to help us actually insert those NVMe drives from an M.2 into a U.2 configuration. Okay? And lastly, we want to be cost optimized. This is the open hardware that we are driving into cost optimization. Cost optimization is very significant for us when we go to large footprints. When you buy 500,000 servers, every server is significant. Every $10 in every server becomes $5 million. So it's a very significant situation. That's why we actually want to exhaust the technology that we can. And if we have an NVMe drive, which is 1T in one server, it has to be utilized. It cannot sit there with only 100 megs sitting on it, doing some logging, and the rest of it sitting idle. Technology of sharing off NVMe fabric combined with any other software combination give us the ability to actually optimize the cost of our environment. Okay? So let's jump in and see what is Open19. This is Open19. What you see over here is 4 cages. This cage is an element which is a passive element, which is sitting inside a rack, a 19-inch rack. It defines form factor for 3 types of servers. Something we call a brick, which is half width, 1 RU. An element which is a double wide brick, which is a standard 1 RU, full width. And a double high brick, which is a 2U solution. We went back to the 1 RU, 1.75 inch, that serviced the industry for the last 5 decades or 6 decades. and did not feel that we need this extra 0.3 inches that some of our peers are trying to
Yeah,
add.
well, we can talk about what the idiots your peers
Yeah.
are later. But so the brick cage doesn't reduce the available width between the rails?
It does not.
Okay.
It's sitting on the edges. It's creating the slots. And you can see over here, it's actually a dynamic slot environment. Every 2U can be converted to be either 4 half-width bricks, it can be 2 of the double wide, or it can be 1 of the double high.
Is double high double wide, or?
Double high is also double wide.
Okay, so there's,
Yeah.
so it's 1, 2, or 4?
Yes. Now in this configuration with this septum in the middle over here, you can also do a half-width double high,
Right.
which we at this point did not see the right application for it, so we decided not to define it at the form factor.
That's the, I need a lot of PCIe slots in the
Exactly,
back.
but it's completely straightforward and simple to do that. We had 2 common elements in the Open19. One is a switch, and the other one is a power shelf. We do power distribution through a power shelf. Power shelf takes the drop from the ceiling. We created a power shelf which is very dynamic and very easy to use. It has a full range of the AC from 90 AC to 277 AC, and the full range of DC from 277 to 480. Same power shelf, same power modules, the same power distribution. We are distributing 12 volts in the back. And the reason that we're distributing 12 volts, even though 48 is the latest hype that Google is trying to drive into the industry, is that we went to all of our server suppliers and we asked, what is the voltage your motherboard is taking? We got 100% response, 12 volts. So if we distribute 48, we have to do another stage in our servers to actually do 48 to 12 and then push it to the motherboard. We had a goal to actually reuse motherboards. Take the motherboards that exist and just repackage them to this form factor. And that goal actually forced us to go to a 12-volt solution. And we allocated for each and every one of them enough bandwidth and enough power to be able to take those motherboards as is. As a result, we have currently 10 suppliers of servers which are building servers to this form factor. Now let's take a look at the back of that. Let's take a look at the back of that cage. What you see over here is some of the tricky stuff that we did. We created a snap-on cable, which is a cable which just snaps to the back of the cage. It does not need tools to connect it. It does not need anything which takes more than 20 seconds to actually attach it. And it's creating a virtual chassis for those racks. And the servers that come in from the front, in this side, these servers will just blind connect into that cable, which is showing over here. We did this for data and for power. Each server, which is a half-width server, getting 100 gigabits per second, and gets 400 watts. And it goes linearly. So if you go double wide, you get 200 gig, 800 watts. If you go double high, you get 400 gig and 1600 watts.
Okay, when I slide the server in, does that automatically mate, or
Yes.
do I connect the cable?
No cables.
Okay, so
Blind mate.
there's an intermediate.
Exactly. So the way it works, the way data centers are going to be installed for LinkedIn in the future, we're going to roll the racks in, we're going to put the cages in there, we're going to snap the cables in the back, connect them to the switch, connect them to the power, and they will sit there, waiting for demand of servers. And then our apps team come in and say, okay, I need to push 5,000 servers into this location. We just push 5,000, then it's Lego, right?
Yeah.
Because it's just put server number 1 in slot number 1, server number 2 in slot number 5, and just repeat this 100 times. And that's what makes the integration extremely fast.
Okay, and the 10 gig is fiber on that connector?
The 100 gig.
100 gig, sorry.
It's 100 gig. It's 4 channels of 25 gig for each one of the servers.
Okay.
So, and it has, the cable and the connector have been defined to actually accommodate 56. So we have built in 200 gig per server, which we believe will hold the whole industry that will adopt this for the next 4 to 5 years. And then beyond that, there's already partners that we're working with to create an optional optical version of that. The same snap function.
Okay, so this is copper.
Yeah. The same snap function, the same blind mate connectivity, just based on optical interconnect,
Right.
using onboard optics or using any other kind of optics connectivity. Okay. So in summary of the form factors, 3 form factors for the bricks: brick, double wide, double high, linear growth, The next item is really important, self-sustained. And that goes to our concept of disaggregation. Each one of those servers, when you buy them from HP Enterprise, from Supermicro, from Quanta, or from Cisco, doesn't matter, they will come with a UL sticker for safety, and they will come with an FCC sticker, means they are EMI compliant. When you do the rack level integration, you don't need to worry about this. Those elements are completely self-sustained. And lastly, they're self-sustained from a cooling perspective. Each element can cool itself. So you don't need any cooling assist in your rack. You don't need any situation where you have fan doors or anything which is centralized to the rack. If you have them, that's fine. They will still survive. They will just spin their fans a little bit slower inside, but you're not required to have them.
And it reduces your density efficiency also.
Absolutely. Absolutely. This is the cage. This is a real picture of the cage. It has two versions, a 12RU and an 8RU version. So you can take 24 bricks or 16 bricks. We created the 12 and 8 because the combo of those two can actually cover almost any type of regular rack that you can see in the industry to fill anything between 40 servers to 96 servers per rack. And they take the 2RU modularity we talked about, and they have the snap-on in the back, which actually where the cables snap into them. It's completely passive, and it's very, very cost-effective. It's a few hundreds of dollars. That's
Yeah,
what it costs.
it's just sheet metal.
Exactly. It's
And
just
the
10 sheet metal.
connectors at the back, yeah.
Yeah. You can see over here the septums which are being pulled in and out and actually enable you to reconfigure it. This is a switch. Again, it's our design. Initially, we have only 3.2 terabit switch in here because that's the biggest one we can buy from Broadcom today. And what you see over here is very interesting, right? You see this connector? This connector is a 96-channel connector. It's replacing a significant number of QSFPs in a single connector over here, and it terminates the snap-on cable. So the snap-on cable, which gives 100 gig for every one of the servers, terminates into this large connector over here on the bottom. And we have 800 gig worth of bandwidth reserved either for uplinks or for equipment which is not Open19. So let's assume that you have something special which does not fit into this form factor and you want to insert it into your data center. You can use some of those ports to do that. It has a relatively strong CPU, a Broadwell DE, to help us do fast convergence because all of our data centers are fully routed today. Okay? It's our design. It's a white box from LinkedIn. We will completely open it up into the industry and give it up to everybody. We'll do a real open so people can replicate it, not an open, half-open spec. Okay? This is a sample of the power shelf. This is a power shelf from Bell Power. There's a similar one coming from Delta. You can do two versions. We have a 1RU 9.6 and a 2RU 19.2. Depends on your configuration on the rack and the location and how much you can actually consume. You can actually do this. If you take a 9.6 or 19.2 and you want to push full 400 watts for every server, you have to run power management system. If you don't want to run a power management system, you limit your servers to 250 watts, then you don't have to run anything. It will actually work by itself. The cables, connectors, and interfaces are all designed for 400 watts for every half width, or 800 watts per RU. Okay? It's multi-source. Both of them will take the same modules. And like I said, both of them can do AC or DC. The way we built the different location adaptation is those power shelves in the back have connectors which are generic connectors, and we have what we call whips, which are cables we connect on the back to adapt it to the current location. So if you're in the European data center and you have a special power distribution which is not US standard, you just build another whip. It's exactly the same shelf, nothing changes on the shelf, just a piece of cable that connects you to the data center infrastructure. This is a configuration that we are testing and we're actually building and plan to do that. If you look at this, you see over here 3 racks connected with the top of racks. There's an interconnection between them going through our fabric, which does not show over here. This is a top of rack switch, which aggregated this configuration. We have compute nodes over here. These are not Open19 compute nodes. This is actually an older version of the picture, but the compute nodes that we have will look very similar to that. We have a NIC in every one of them. It can be 25, it can be actually 10 as well if you want, but we are planning to do 50 for each and every one of those. And then we have NVMEs. A combination of NVMEs for us is between 2 per socket to 16 per socket. So those are the ranges that we're operating under. And we will have what we call a storage server with 16 2.5s, and a standard compute server which has a lot of sockets on it, but only 2 per. We are heavily, like I said, doing NVMe, and then we run the NVMe mesh on top of this to enable full sharing. This is showing 3, but the typical row for us is a 24 cabinets, and the typical data center for us is over 100 rows in length. Okay? So this configuration shows you how this links directly to Open19. The technology of the server is what lets us actually run the client on every one of our bricks. And since we're heavily NVMe, it's a perfect match for us. And that's why we're collaborating with Accelera on this technology. If we look at the benefits, any 19-inch rack, that's the key. Every location that will go in the world, every colo, every private location, or every somebody's garage, what you will find is a 19-inch rack. You will not find 21 or 24 or anything like that. It's completely disaggregated. All of the solution is every element is independent. We have no relationship between the server, which is in slot 1 and slot 2. You can put a Cisco in slot 1 and a Supermicro in slot 2, and they don't know about each other. They just connect to each other through the network fabric. So we're completely disaggregated, and they're not going to impact each other from an EMI or from a cooling perspective. They're completely independent. We're extremely power efficient. The total rack efficiency is at over 96% because of the power shelf distribution. And we believe that when we eliminated the power supplies from all the servers, we actually not only reduced the cost of the servers, but also increased the efficiency of the rack level.
Right, and the power supply in the server gets replaced by some DC to DC converters to generate the lower voltages.
Absolutely, on each server, which is pre-designed. It was there to start with. Just before, they were doing 2 stages. They were doing high voltage to 12, and then 12 to the low voltage.
Right, and you just
now
lost...
we just got rid of the high voltage to 12.
Right.
We do it in a centralized way, in a much more efficient way. We can do battery backup if you do battery backup per rack, if you feel like doing that. We can leverage existing servers. Like I said, when we did the polling of all of our server suppliers, we asked, what's the voltage? But we also asked, what's the size of your motherboard? So we got dimensions of motherboard, and we made sure when we define the form factor of the Open19 servers, which is basically what it is, we made sure that everybody can take the motherboard as is and put them in. So that's why we will see in the first 2 months of deployment, tens of those servers coming in from different suppliers.
And most of them double wide?
No, actually, most of them are half width. Most of them are the brick size. Okay? And lastly, I think the solution right now, the way it looks like, it's probably the most cost-effective in the industry because we reduce the cost of the servers, we reduce the cost of the racks themselves and the built-in. We eliminated all the cables, just rough numbers on the cables. Typical cable to connect 100 gig to a server, that cable is between $60 and $80. In this architecture, we're sub $10 per server. Just by that, we knocked down $70 per server. Multiply by 100,000 servers, just get yourself a nice check back.
You guys have, as opposed to OCP, this makes sense for 1,000 servers. Where OCP is, unless I'm building a new
500,000 servers.
500,000, yeah.
I agree. And lastly,
because on the enterprise side, I may still have appliances and it's still a 19-inch rack, and I can just
completely okay.
Just put in one less frame and use the bottom.
And a new business model that we've seen actually emerge. Some of the people like the Equinixes of the world and the Digital Realty and some of the European operators that used to just give buildings, right, with cooling and power. I said, okay, why should I just give the building? Now I can fill it up with racks full of Open19 gear.
Yeah.
I give empty slots and I start going to lease slots. This is in reality an emergence of the bare metal cloud. Because if I am coming from a place where I need just 2,000 servers, but I don't want to put them in the cloud, I want to maintain them, I will go to Digital Realty and say, okay, I want to lease from you 2,000 slots from the Open19 form factor. And here's the server that I want. I can bring my own server, or you can lease from me a server. HP is already building a plan for lease servers of Open19, HP Enterprise. So the whole configuration, the ecosystem is actually growing and becoming really, really strong. Speaking of, we have a very significant global attention right now. These are just part of the partners that we have. You can see from here that we started building our ecosystem from the component level to the system level, and only now we're finishing with our peers. So you don't see a lot of peers of us over here. Actually, you see none of the peers of us over here. But I can guarantee to you that all of our peers, mid-size plus, are involved. Okay? We're building a nonprofit. And the reason that we're building a nonprofit is that we wanted to contribute initially to OCP. A lot of our partners over here came and said, if you contribute to OCP, we're not participating. Because OCP is requiring us to actually expose our IP, and we will never do that. So we said, okay, that's cool with us. We'll build a new nonprofit which actually defines different type of bylaws which enable you to participate, to adopt, and to contribute as much as you want. So if you don't want to contribute and don't want your IP exposure, you don't need to. But if you want to contribute, you can contribute in a safe environment where the IP protection will happen, and people that adopt your technology are fully protected.
Okay, the only thing I see missing is a provision for out-of-band IPMI-like management.
Oh, it's in there. If you, I didn't talk to it, but
that
when we
cable has another
that
channel
cable
for that?
has an extra channel in it, which is running 1 gig from every server, as well as 1 gig from the power shelves. And it pulls out of the rack with a single cable. Or dual if you want redundancy.
Yeah, for the smaller size environment, I'd like to see something like the network shelf.
Yep.
That didn't have smarts in it, but was just a breakout to standard connectors, because we really love brand X switches and we want to keep using them.
You can do that. You don't have to use the special switch. There is an option for this cable to be bought with QSFP at the ends of it. So you can buy a Cisco and just terminate
and
this
break it out.
And break it out as a QSFP.
Yeah.
We hope that we'll convince people that the value that the new switch is giving, integrating out-of-band switch and integrating data
at a
path,
10th your scale it does, at a 100th your scale it doesn't.
Yeah, cool. We have over 75 companies right now involved. You will see in the next 6 weeks a lot of announcements. We have a countdown on our website, which is counting to the first live demo we're going to do in Hanover in Germany at CBIT. And after that, you will see people joining, people announcing their support for it. You will see demo of multiple server suppliers that will be with us in CBIT, etc. So in summary, we have a very global and strong market attention right now. We're building a nonprofit. We're enabling IP protection. We're creating a solution which is disruptive to how data centers are being built. And it didn't start like that, but it ended up like that. And we have no doubt in our mind that we are disrupting the industry. And we're including disrupting our new mothership, coming from Microsoft, which is actually looking at this and say, okay, this is interesting. Even though they have the Olympus system, but this is interesting enough for us to use this in certain locations where we actually do not use the Olympus system. The Olympus system covering 80% of our footprint. There's an extra 20 that we need to deal with. This is definitely a place where we can actually...
And Olympus is the system we read about a few months ago.
The OCP one, yeah. That were announced in
with a
November.
lot of M.2 slots in the front, yeah.
Right? Any questions?
Yeah, what's the nonprofit organization about?
What is it for?
Yeah.
It's to enable to create a community.
It's a federation of...
It's a foundation that will enable us to create a community for people to come and contribute technology with IP protection, and at the same time consume the technology and maintain IP protection if you want to. Or for software and for hardware, we already have 2 hardware projects and 2 software projects lined up. 2 of them coming from LinkedIn. One is coming from a company Vapor.io, which is running OpenDCRE, will be contributed over there, and one is coming from Broadcom.
In order to benefit from this NIV compute platform, 100%, is LinkedIn planning on rolling back that horrible UI they rolled out not long ago?
I'll take the fifth on that one. All right. Thank you very much, guys. I'll hand it off to Lior.
So guys, respect to the fact that we are number 4 today. Really, you guys, this is your tech field day number 4 of the day, right? So I will only take 60 more seconds. First, Yuval, thank you very much for coming, spending the time and presenting Open19. On a personal level, I'm an evangelist for Open19. We talk with our customers about that because it makes a lot of sense and it helps us position our solution as well. And of course, Excello as a company, we're going to be a member once they start, we'll officially launch. So hopefully today was a good day about technology. And I'm happy that you saw a live demo. And I'm happy that Yaniv got to talk about all the cool stuff. But when you think about us at the end of the day, and that was what I was trying to say at the beginning, and I was kind of nervous, is that we're not launching a technology today. We're excited about the technology, and that's why we started, but we're launching something new in the shared accelerated storage space. We're launching a company with customers and a version 1.1, with partners, with soon to announce OEMs, with huge partnerships in the field. That's why I think it's different than what the other announcements of, let's look at our cool technology, but, where's the business behind it? I've been doing business in this space for the past 20 years, and, we really want to build something that will change the industry, and that's what we're trying to do here. So I really appreciate the time. Thank you very much. I'll give it back to you, and thank you for organizing this perfect event. Thank you.